All right, we're going to continue with our fraction review, and again with our intermediate level math, you're going to be doing, well, this, you think about it and you tell me, I won't tell you. Of our 7 steps of the teaching progression, which one are you doing the most? Yes? Expansion. 5th and 6th grade, well, with 5th grade, you're going to be really centering in on division, because they will not have done very much fraction division. They will not have done enough decimal division. So 5th grade is an important year as well. It's not just review, not just solidifying. 6th grade is as well. But you will be doing a lot more of procedures and taking things further with expansion. So with that in mind, since we are doing a lot of expansion in 6th grade, 5th grade, and even 4th grade, every year has its concepts. I do want to stress to you the idea of providing your students with more tools in their toolbox. Okay, because as the problems get longer in procedure, as the problems get harder, as we have more digits, or even with division, as we add the decimal point and things to our basic long division, we need to have tools in our toolbox. So we were starting with, and I'd like to go back over and finish reducing. What are the 3 tools in our reducing toolbox? First one, yes. The times tables, yep. The times tables work very well as far as simple reducing, and that would be the first way that you would reduce. You would think of factors. What is the greatest common factor? You can find your of course, reducing, to reduce a fraction, we are going to divide by the greatest common factor. And so the tools in our toolbox are to help us find the greatest common factor. And with the first tool, the times tables work very well, especially in not first grade, they don't reduce fractions. In 3rd grade, they start reducing just a little bit, but in 4th grade is a time where they really learn to reduce, and most of your 4th grade level fractions are well within their times table range. And so they will recognize the factors by thinking through the times tables. Second tool. Yes? Divisibility. The divisibility rules. And these also then lead naturally to the 3rd tool for college level, high school level. What is it, Rebecca? Prime factoring. And of course, as you'll be taking quizzes and tests on basic math skills, the reducing that you have to do for me is this tool's not gonna help you a whole lot unless you want to spend time doing repeated division, and so forth. Even the divisibility rules are going to require you to do multiple steps. But if you use the prime factoring, it's much easier to it gives you steps to do instead of sitting there and staring at it and trying to think of common factors off your top of your head. That's what you're doing with the times tables. You're looking at the problem and you're thinking of something in your times tables off the top of your head. But with the prime factoring, you can reduce any number by putting it into its prime factored form and then canceling. So let's just review. 24/36 is one that we brought up last time. Here's another one, 45/55. And 42/75. This one is a good illustration of the times tables are good enough. If you know your 12s, you're going to recognize that immediately. And actually, your 5th graders ought to know their 12s. And if they don't, you need to work on it in drill. They ought to know their 12s well enough to be instantly recognize 2 times 12 and 3 times 12. So here we just use our toolbox. And if the reducing is easy, you're not going to prime factor that. You use the tool that fits. All right, this one, maybe not the times tables, but here's an easy divisibility rule one because of the glaring 5, right? So what's the greatest common factor here? 5. And it's easy to see by the divisibility rules that both of these end in 5. They're divisible by 5. I'm just going to mentally divide the numerator and the denominator by the greatest common factor, 5. Okay, so you use a combination of tools. What are the divisibility rules? What are they? The most important divisibility rules are for the prime numbers, 2, 3, 5. 7 does not have a divisibility rule. 9 has a divisibility rule, but it's not prime. So you wouldn't use it in prime factoring. But the divisibility rule for 2 is what? Yes? Even. So we have to train our students never to leave even numbers unreduced. They can at least start with the 2. Another thing that you can do, hopefully you're making some blank flashcards, especially if you end up student teaching a math class, because then you can use reducing off the top of their head their divisibility rules and their times tables on reducing flashcards. And that way the students are trained that when they see 2436, that just looks bad to them. They won't leave it that way. And that a lot of that can be done by flashcards. So an unreduced fraction simply looks wrong, okay? And if you can train your students to recognize things that look wrong or that need to be further reduced or need to be further simplified, that's a big step in helping them with their math skills. So what is the divisibility rule for 3? Go ahead, Morgan.
Sum of the digits is divisible by 3.
Yes, so here, when we're divisibility for 2, we're looking for even numbers. Here we will sum the digits. If the sum of the digits in the number, even something as simple as 24, the sum of the digits, 2 plus 4 is 6. If the sum of the digits divide by 3, the whole thing will be divisible by 3. You can see 45 is divisible by 3, but it is also divisible by 9. So 5, there's really not one, 9 and 10. Divisibility rule for 9 applies in the same manner if we sum the digits. If the sum of the digits, 4 plus 5 is 9. If the sum of the digits divide by 9, the entire number divides by 9. 5, divisibility rule for 5. Go ahead, Rebecca.
If the last number
Ends in 0 or 5. And that's a very easy divisibility rule that can be applied pretty easily to reducing. The divisibility rule for 10, of course, ends in 0. And so when we're canceling a 0, what we're actually doing is dividing by 10. There are divisibility rules for both 4 and 6. And 4, since 4, we'll go ahead and pull it over here, since 4 goes into 100, any multiple of 100 divides by 4. And so then once we get past into the hundredths place, we don't have to consider it anymore. So the divisibility rule for 4 is that if the last 2 digits divide by 4, the entire number divides by 4. And many books will also add the little addendum, double 0 divides by 4. And that's simply because 4 goes into 125 times. So then once we start working with our larger numbers, if the last 2 digits divide by 4, the entire number divides by 4. Okay, so 124 is going to divide by 4. What about 384? Is that divisible by 4? Yeah, 4 on the end's kind of a dead giveaway. Maybe that's not a good example. But there are divisibility rules for 4. Again, that one's not as useful because we have 2 and it's not a prime number. There's a divisibility rule for 6. What would it be? Yes?
In the last, well, it's an even number, it is divisible by 3.
And how did we get that rule? We combined 2 and 3. So if we combine the divisibility rule for 2 with the divisibility rule for 3, we get the divisibility rule for 6, which brings us up to the importance of prime numbers versus composite numbers that I want to take care of when we do the main part of today's lesson, which is common denominators, and least common multiple versus greatest common factor. Okay? All right, so tools in the toolbox. Here's our main tools that the 4th graders, 5th graders, 6th graders will use. Junior high's got to start transitioning into the prime factoring mode. We're actually preparing them for algebra. And as a college student, when you take a skills test from me, I am not going to give you this type of reducing, am I? It's going to start here. This one we could use divisibility rules. We can use the fact that this is 7. But it's just, this one is, if it takes too long to immediately come up with the greatest common factor using your times tables and your divisibility rules, then those aren't good tools, are they? If you have to stop and think and do a couple division problems on scrap paper or a couple division problems in your mind, this is just not a good tool. That's why we want to, when we're teaching procedure, especially when we're expanding procedure, we want to be giving them more tools in their toolbox. So prime factoring, get rid of these. Prime factoring, and come back to this guy, prime factoring is an important intermediate skill. Okay, so we want to address it. And it's an important intermediate math skill because it will be used in high school. I use it so much as a high school math teacher that I do a lot of prime factoring in my head because I'm so used to seeing those numbers, I can very quickly turn them into their prime factored form. So prime factoring is an important intermediate skill. Sometimes don't fall into the trap as an elementary level teacher, even an upper elementary teacher, to go through your curriculum and think, why are they teaching that? I've done that a few times. And then I've caught myself saying, oh, they need that in Algebra 1. Even though it's not something that the 5th grader or 6th grader might be using right now, it's something that is building their math foundation for the future. In 7th grade math, we are doing measurements. And part of the measurement chapter in the 7th grade math book is precision versus accuracy and significant digits. And they're having difficult with it. They get a difficult time with it. And the temptation for me is to skip it, right? After all, they're 7th graders. They're not doing precision and accuracy. But when will they need precision and accuracy? When will they need those significant digits? Physical science, chemistry, physics. So hey, how about introducing it? Maybe they'll struggle with it and they won't get it in 7th grade. But what does that do for them the next time they see the significant digits? It'll eventually be, we did this in 7th grade and I couldn't do it, I didn't understand it, I got bad grades here. But then the light bulb is a lot more likely to come on in 10th grade when they've had experience with the significant digits. Because part of the reason why they can't do it very well in 7th grade math is because they don't use it. And so it kind of falls by the wayside. So I'm thinking, oh, let's just skip this. They're not using this yet. But that's not a good idea. I already know they're going to do bad on that section. I already know some of them just are not going to catch what I'm doing. Some of them will. But at least we're giving them experience with it. And then in 10th grade, it may even be me as the physical science teacher, when they are required to do the significant digits in the physics section, they'll at least have experience with it and it won't be something out of the blue new. It's out of the blue new for the 7th grade. So as you are teaching in an intermediate, prime factoring is something you might think, oh, what's the big deal? Or if you're a 4th grade math teacher and they introduce prime and composite, but then they leave it alone, they don't use it. And you might think, oh, that's not a big deal. I'm short on time, I'm going to skip it. But then, when we really start needing it in algebra, we start needing it in 8th grade math and 7th grade math because we're doing harder reducing, we are starting to do things in a more high school way, we're starting to do things in a more algebraic way, then it'll be brand new out of the blue. And it'll be a whole lot better if they already had it brand new out of the blue in 6th grade and 7th grade, so that's not so foreign to them. After all, when I'm teaching 10th grade physical science and we're doing physics problem and we're trying to learn about momentum and we're trying to do acceleration due to gravity, it's really hard to have to keep tripping over the significant digits. And as the teacher in 10th grade, I have a decision to make. Am I going to dock them for the significant digits, or I'm going to say, oh, it's okay, they don't have the significant digits? And actually, I do not want to do the latter, do I? So be careful about skipping stuff. And so that's part of the purpose of this class. Don't skip prime versus composite in 4th grade or 5th grade just because they're not going to use it yet. A well-designed curriculum will throw those things in to help build the math foundation. So anytime you're teaching with primary, you're really building math foundation. But even as you're getting into the immediate grades and you're teaching expansion, are you done building the foundation? No, now instead of building the foundation for arithmetic, you're starting to build a foundation for high school math, high school science. Okay, so don't skip the prime factoring. So with prime factoring, what is prime factoring? Prime factoring is when you take a composite number and break it down into its prime factors. There are basically two types of numbers in arithmetic: prime numbers and composite numbers. Prime numbers, what is a prime number? It's any number whose only factors are 1 and itself. Okay? An exception would be 1. 1 is neither prime nor composite because, well, it is the multiplicative identity number. It does not count as a prime number. 0, 1 and 0 are special numbers. 0 is the additive identity number. So when we're dealing with 0, remember we can't divide by 0. 0 has quirks. 0 is even, but 0 is not prime. Okay, think about 0. Are its only factors 1 in itself? No, 0 times 1, 0 times 2. So 0 is a different type of number altogether. 1 also is considered to be neither prime nor composite because 1 in itself is 1 is itself. So 0 and 1 you have to be careful with, and they have special places and special uses in arithmetic and in other areas of mathematics. Remember that 0 is the additive identity number. What does that even mean? Do you remember the identity principle? What does it mean?
Anything added to 0 is itself?
Yes. Any number added to 0, or usually you say it the other way. 0 added to any number retains its identity. It stays the same. That's called the additive identity principle. A plus 0 is still, almost wrote 0. A plus 0 is still A. That's the added identity number. The other thing with 0 is the additive identity, which means it's the result of additive inverse. So 0 and 1 do not fit our prime numbers or our composite numbers. So 0 is the additive identity number because 0 added to any number retains its identity. It stays the same. And then 0 is also the result of additive inverse. Any number plus its opposite equals 0. So 0 is the result of additive inverse, and it is the additive identity number because any number You add 0 to any number, it's still the same number. It retains its identity. We have to teach these principles to 7th graders and even 6th graders. Remember, associative property, commutative property, inverse property, identity property. And so we'll cover that at another time. But that's why 0 is even because it's divisible by 2. But 0 is neither prime nor composite because 0 is the additive identity. And by the way, 0 is neither positive nor negative, is it? You don't put a sign with 0 because positive numbers are numbers to the right of 0 on the number line. Negative numbers are numbers to the left of 0, so it can't be left or right of itself. So 0 is a special number. Also remember that you cannot divide by 0. 0 in the denominator is not plausible. So we have to be very careful with 0. It is the additive identity number, and it is also involved in additive inverse, and you may not divide by 0. 0 in the denominator is said to be undefined. Why is that? This is nonsense. Remember that symbol? Null set. That means the set of possible answers is empty. There is no answer here, no solution. What about this? We have to be careful with 0. And so you have to address it and you have to be aware of it yourself. What is this? Yes?
0.
This is 0, but this is nonsense. This is undefined. It's undefined because how do we define division in terms of multiplication? This is asking 3 times what number equals 0? That's fine, because remember, division is defined as the inverse of multiplication. It's defined based on multiplication. So when we're saying 3 divided into a 0, we're asking 3 times what? Remember, times what is kind of a simple way to express what division means. So here I'm asking 0 times what equals 3? Not possible. All right, we can't divide by 0 because 0 times anything is 0. It'll never be another number. Remember, in fraction form, this is the dividend, this is the divisor. So we have to be careful with 0. It is neither prime nor composite, okay? It is neither positive nor negative. It is not prime or composite. It's not negative or positive. It's only an even number, okay? It is the additive identity. What about 1? We'll come back to the prime factoring, but we've got prime numbers, we've got composite numbers, and we'll do special numbers. 1 goes in the special number category, doesn't it? Okay? What is 1? If 0 is the additive identity, what is 1? Yes? The multiplicative identity. And multiplicative identity states that any number times 1 retains its identity. So 1 is the multiplicative identity number. And that is also related to inverse. Any number times its, what do we call this? Reciprocal equals 1. So 0 is involved with canceling when you add. It's the additive identity number. It is the result when you cancel addition, you get 0. The same is true with 1. 1 is the multiplicative identity. It does not change when you use 1 as a factor. It doesn't change the product. Just like when you use 0 as an add-in, it doesn't change the sum. And it's also involved in canceling. What do you get when you cancel? And nothing is left. Well, that's not true. Something is left. What is left? 1. So when you cancel add-ins, you get 0, the additive identity number. When you cancel with multiplication or division, you're left with 1. 1 is the multiplicative identity number. It is also the result of multiplicative inverse. When you multiply by the reciprocal and the numbers cancel, you're left with 1. I still have students in 9th grade Algebra 1 that when we get a rational expression, I guess I'll stick with 3. Ouch! Somebody missed identity and inverse when they were in junior high. Correct? They thought, oh, I don't need this. It's just a little technicality. Well, it's not just a technicality, though I can understand why sometimes you might think, oh, who cares about this? All right, so special numbers are 0 and 1. They are neither prime nor composite, though they are even for 0, odd for 1. So you can still do evens and odds, but can't put a sign on 0. Because it is the defining point of positive and negative numbers. All right, so prime numbers, only factors are 1 and itself. Composite numbers are numbers that are made up of repeated prime factors. Composite numbers are numbers that are made up of repeated prime factors. Okay, so let's take the number 24. 24 is composite. It has several factors besides 1 in itself. There are 2 ways to prime factor. When we're doing prime factoring, we have to remember the smaller prime numbers. I used to tell the 6th graders 2, 3, 5, 7, sometimes 11, rarely 13. 13. Remember, I mentioned the fact that once we get into 6th grade and we're bored with the 1 through 12 times tables, what should we do? Introduce 13, because 13 is a prime number. You can do 14 and 15 too. That is helpful for them, but 13 is very important. Otherwise, your students are going to be like some of my college students who always miss reducing problems with the 13 because they don't know their 13 times tables, okay? Or they didn't prime factor. So there are 2 ways to take a composite and factor it into its primes. The easiest one is the factoring tree. The factoring tree allows students to go through their times tables. When you see 24, when I see 24, I normally think 3 times 8 comes to my mind first. Not 6 times 4, I don't know why, but 3 times 8 comes to my mind first. It really doesn't matter which one comes to your mind first. The result can still be the same. You might think 2 times 12, I don't know. So when you use a factoring tree, you keep branching down until all of your tips are prime. 3 is already prime. 8 is 2 times 4. 4 doesn't, I got to keep going. 4 goes further. So I keep my branches all in a row. I don't want to forget to come back and get the 3, do I? Keep everything in a row. And that's another thing to think of. When you're teaching procedure, have things organized and neat so you're not causing your students to make dumb mistakes. So do I have to bring down the, oh, look what I did. Do I have to bring down the 3? Yes, I need to bring down the 3 so that I can see my composite numbers primes. So 24 is 2 times 2 times 2 times 3. Then I'm using dots because of the habit that I have. Lower elementary, you can still use the times. And then as you start proceeding, what should you do next? Even if it's not in your curriculum, you could even say exponents. A better way to write this is 2 cubed times 3. So even when they're not really doing the exponents yet, I'm always getting them ready for the next step, so that they'll be more familiar with the exponents when they've seen them, they've seen them, they've seen them, they've seen them, okay? Same thing with a lot of different things that we're doing. Even the principles, associative, commutative, inverse, and identity. The more they see them, the more that they will recognize them later on down the road when they have to use them. So I'm the intermediate math teacher. I have 5th graders, I have 6th graders. My job is to start thinking ahead. What's coming up in junior high? You say, well, I never taught junior high math, I'm not you. Well, then you need to trust the curriculum. And before you decide to cross something out because they don't need it, think it through. They may not need it right now, but they might need it next year or next year, okay? So this one, it really doesn't matter. I'm going to get to the same place. And actually I got here sooner and neater. What do I mean by neater? Morgan?
It's in order.
It's in order. So maybe I am the 5th grade teacher, maybe I am the 6th grade teacher, and it doesn't matter if I write it 3 times 2 times 2 times 2, but why don't I go ahead and have them do it in proper format, even when it's not required? So I always try to do things in the proper format and the proper order, even though maybe at that point in time, it doesn't matter. Okay? Well, it does matter. Maybe I'm not going to require them to write it in or dock their grade. Maybe I'm not going to dock their grade because they didn't put it in order because they're 5th graders. Or maybe I'm not going to dock their grade because they didn't use the exponents, but I'm going to encourage them to start from the beginning doing it in proper format. Okay, on the side note, even if things don't matter, we should still try to do them right from the very beginning. Sometimes I have trouble with 9th graders who do not put things in proper order. In algebra, if you think about polynomials, polynomials have different algebraic terms like x squared x or x cubed x squared x. What do you do in algebra? You put them in highest power first. So even though I'm teaching pre-algebra in 8th grade and a little bit of pre-algebra in 7th grade, I'm not going to write my terms backwards. Well, it doesn't matter, they're only in 7th grade. Wait a minute. Think about what I just said. It doesn't matter? Well, if it doesn't matter, why am I teaching it? Okay? And so there really shouldn't be any time where you think, oh, that doesn't matter. Oh, be careful. It probably will matter in 9th grade. And then you're establishing a bad habit. Okay? Think about, before you know it, you'll have your own children and they'll be in school. Or you'll be schooling them. Think about it. Do you want to have them establish the bad habit of when you teach them how to write? Okay. Do you want to teach them bad habits about not capitalizing the first letter of a sentence, or not capitalizing their name, or even, that's a dumb example, I realize. But think about always doing it right from the beginning, even if it doesn't exactly matter at that point. It will matter later. So I am going to always write it properly. Even if I'm not holding my students responsible yet to write it properly, I'm going to. And that's why when you're teaching fractions, a good curriculum that puts out good problems will always use prime numbers as the denominator when they're first teaching addition. That way they're never showing students fractions that should be reduced until you're ready to show them fractions that need to be reduced and what needs to be done about it. So always try to do things properly. I do get irritated a little bit with some of the curriculums with respect to metrics. They're trying to introduce metrics too soon, and they're teaching students to convert metric conversions before they know decimals. And so they're getting the wrong impression about how the metric system works. To me, it's better for you to ignore the metric system than for you to teach it in a wrong way. Because then you've got this misconception, and then they get to 7th grade, and they can't do metric to metric conversions because they try to do them like they were US customary units, and they try to do the cancellation of units on them, and they get it mixed up between the two. So try to always be aware of the proper way to write things and things that are coming down the pike for them later. So our composite numbers, okay? A composite number is going to have repeated prime factors. The second way that I could prime factor the 24 in our example is division by primes. Division by primes is exactly what we're saying it is. That means I use 2, 3, 5s, sometimes 11, sometimes 7, sometimes 11, and rarely 13, and even once in a blue moon, 17 or 19, but not usually that much, okay? If you prime factor with the lower numbers, you're going to get to the 17s and the 19s automatically. We just have to recognize them as being prime. Division by prime, and don't allow them to just pick a number. Oh, that's divisible by 3. My divisibility rule tells me that's divisible by 3. Do we start with 3? Math should always be done decently and in order. There's nothing random about mathematics. Guessing is not a math skill. You say, I thought it was estimation. No, estimation is not guessing. Okay, estimation is simplifying a problem down so you can do it in your head to get a ballpark figure, to see if your real answer is close, right? Guessing, don't guess, no guessing. Okay? Junior high students are really bad about guessing. The Bob Jones curriculum uses a lot of matching. Okay? And I can just see it on their faces when there's a matching section. They think, easy, I don't have to do any work, and they completely annihilate the matching section because they did it like they were taking a standardized test and the proctor just said 1 minute left. You know, so you quick fill in your circles before the time is out, provided they don't penalize you on that standardized test for wrong answers. Some do, most don't. But anyways, so we don't want to guess. We don't want to just start somewhere in the middle. Mathematics is not random. We should always have order that we do everything in. We should not, don't just pull a 3 out of my hat and start dividing. No, I have an orderly way to do this. When I have to do division by primes, that's why I don't like the factoring tree, though the factoring tree helps them because it uses their times tables and it's more familiar and simpler. But the division by primes is a orderly way. You start with the first prime number and you divide by it. Yes, you use your divisibility rules, and if this was an odd number, I wouldn't start with it. I'd skip to the 3. But I start with 2, and you use this so-called short division, where it's upside down, and you do the subtraction and the carrying type in your head. But this one's pretty easy. 2 goes into 2 once, 2 goes into 4 twice. My quotient is still composite, and it's still even, so I start with 2 and I use 2 until it no longer works. Then I switch to 3 if it works, or I go to 5. This will give me 6, so I keep using the 2 until my quotient itself is prime. And then it's already in order. Don't let your students do problems in a random fashion. Make them start at the beginning. It's not random. We're not pulling numbers off the top of our heads. I do have problems with 7th graders that I guess they're used to having the math be easy in elementary, and they're used to just tearing out their work page and working through it and doing whatever process comes to the top of their head. They don't even think to look back at the book to see what they're supposed to do. And so if they can't get it off the top of their head, they just put anything down. Okay, so that's going to be a problem. We never do things off the top of our head. We start at the beginning and we do it decently in order. So when we get back to our 42 over 75, first thing I'm going to do is prime factor that 42, and I start with 2. Okay, so that's no longer even, so I go to 3, and that's an easy prime factor. Right? Then I'm going to prime factor the 75, and that can be done mentally, because as soon as I see 75, I think 3/4. That's 3 times 25, and 25 is 2 5s. Okay? And eventually you can get your students to what? Be able to prime factor in their head. How about flashcards? What have I said over and over again about drill? It's not get on the treadmill that day and recite times tables. It's not get on the treadmill that morning and recite the decimal percent equivalents or whatever you're doing, which you might do in 6th grade. Drill is to sharpen their basic math facts, and drill also can be used to address problem areas, and drill can even be used to help sharpen their mind for the future. So if I hold up 25, I start easy, and ask them prime factors, 5 times 5, or 5 squared. Okay, I can hold up 27. What's 27? 3 times 3 times 3 times 3, 3 cubed. So then that will make your drill time challenging instead of, we don't want to make them into little robots who can chant. Okay? Well, sometimes, I don't know if we're teaching measurements in 7th grade this 3-week period, and they have to convert Fahrenheit to Celsius. Okay? And when they convert Fahrenheit to Celsius, in my mind, I never forget the formulas because I can hear the chant. 9/5 C plus 32, or 5/9 times in parentheses F minus 32. Okay? So sometimes it does help to have some memory, because formulas kind of have a memorization fact to them, a memorization component to them. So it's not a bad idea to recite formulas. So I'm not saying you never memorize, okay, but we want to do less and less and less. So being able to prime factor is something you can do on flashcards with the 7th graders, with the 6th graders. Some years you might even have a small class that's really sharp. I think it's the 11th grade this year. There's only 6 of them. Well, at least there were only 6 of them when I had them in 7th grade. And we had a really good year. Okay? It's always easier to work with 6 instead of 12 or 15. But, and so when you have that, you can do more with them. It's not, the curriculum tells me to do this, this, and this. It's, we're past that. I'm going to drill the primes with them. Then when I have them 2 years later in Algebra 1 and we're doing exponents, they're already going to have that prime factoring down. They'll be able to do it in their mind. Wouldn't it be nice to have things that you can do in your mind? All right? Rather than, and being ahead of the curriculum instead of behind the curriculum with your basic mental math and your math skills. You can really, really, especially in some of the intermediate math grades, you can really take the drill, especially the first part of the semester. You don't want to bore your students, okay? And you don't want to bore your smart students, okay? Right? Now, you don't want to leave your poorer students behind, but you don't want to bore your bright students either. And you can do that with the drill. And eventually, you'll be pulling some of those poorer students along with you. All right, so when I do this, it's been a while since, let's go back to reducing. It's been a few minutes. Why did I prime factor that? So that I can easily see the cancellation, and I'm not doing all this random division, especially when the numbers go to 3 digits. What happens when the numbers go to 3 digits? Okay, I'm going to give you 3-digit numerators and denominators for you to reduce, aren't I? So what am I going to do? I'm going to prime factor. I'm going to take the 126, and I'm going to start where? Where am I starting? 2, because that's even. That's going to give me 63. Where am I going next? But that's 7 times 9. Why don't I go to 7? Out of order. I'm going to use 3. That's going to give me 21. And I'm going to still use 3 until I get it down to the 7. So 126 is 2 times 3 times 3 times 7. What is this? I see that everybody see the 2 5s? Well, where do I start with 175? No. Does 2 work? No, I don't start with 2. Does 3 work? No? It doesn't. I'm going to start with 5. Okay. So that's going to give me 3. With 2 left over, I am going to start with 5. So the only thing I can cancel here is the 7. I don't have a divisibility rule for 7. So I'm going to prime factor that. And that's going to be equal to 18/25. You don't want to be doing all this random division, right? Math is not random. All right. We already did 165 over 660. I think you get the idea there. All right, so I want you to take a look at your math book. As you are teaching intermediate, we have concept, procedure, expansion. What's after expansion? Problem areas, right? Number 1 is terminology, the law of language. Number 2 is facts. Number 3 is? Number 4 is?
Procedure.
Number 5? Number 6? Problem areas. So the further along you are in arithmetic, the more problem areas are going to come up. So we have to address problem areas. Problem areas are areas that are difficult, confusing. They're causing us problems. That's why they're problem areas. So often we will deal with confusing 2 concepts, which is normally seen when we confuse 2 different sets of procedures. So if we're confusing 2 procedures, we are missing the concept. So problem areas when the procedure becomes difficult, confusing, lots of steps, bigger numbers, higher numbers than our times tables, etc. So problem areas involve addressing confusion, okay? And problem areas also can be directly related to harder procedure. We've expanded our basic arithmetic and we have things that are confused because we kind of missed concept, and we have procedures that are harder. We've expanded them, so our lack of understanding is going to become more and more what? Apparent. But sometimes we have problem areas that are just the result of silly mistakes, and that is maybe due to lacking facts and so forth. So with common denominators, with fraction, in our fraction review, the biggest thing that people don't like about fraction math is not multiplication and division. We like cross-canceling, don't we? What we don't like is addition and subtraction when we have to get a common denominator. And often I will not use the word least because, well, yes, you want to use the smallest one to make your math the easiest, but the big thing is having a common denominator. So with us as college students, we can get our common denominator off the top of our head because we've done it a lot. We're very familiar with it. We see the number relationships. We understand the concept. So what I want to review is problems like on page 83, we have college level common denominators. And notice number 78, 6 5/9 plus 6 5/12. It looks like the author got stuck on 6 5, 2 5/18. And that's because they were concerned with common denominator. With the 18, remember that least common denominator is the same as least common multiple. All right? And here we have confusion between least common multiple and greatest common factor. So in this example, with common denominators with upper level addition of or subtraction of fractions, we start having trouble with this and finding this. And so we need to have a good understanding of multiples versus factors. All right, so with this problem, what is the common denominator? Right away, I see, remember we talked about the scenarios? I see scenario number 1 right here. So I'm going to ignore the 9. The 9 is inside the 18. So my main thing that I'm going to deal with when I find my common denominator is concentrating on the 12 and the 18. There's multiple tools that you can have in this toolbox. Times tables. We can even have a formula. We have our times tables. I don't like formulas, but it's kind of neat to see it. And it's also even better if you can derive it as a teacher. If you have 2 multiples, how can you find the least common multiple? We're not worried about the 9. The least common multiple is always going to be the product of the 2 numbers divided by their greatest common factor. Let's try it on 12 and 18. What's the product of 12 and 18? Well, I don't know about you, but I am never going to multiply 2 numbers together just to divide them again. So in my formula, I write 12 times 18. I don't actually do the math. Like I said, why would I multiply something just to divide it back? Which is the idea of cross-canceling. What's the greatest common factor between 12 and 18? What do they both have? 6. Right? So then I'm going to reduce this. So my least common multiple is 36. Staring at the 18 and the 12 for 5 minutes is not going to come up with the 36, is it? Okay, so I can, on the smaller ones, I can do my times tables. This is denominator scenario number 3. My denominators share a common factor. In fact, my denominators share a common factor of 6. So I eliminate my 6 from the product. Does that make sense? That doesn't work very well with 7th graders or 6th graders. So you should have a procedure that helps them organize their times tables. And so a better procedure involves multiples. After all, what are we looking for? We are looking for multiples. So I start listing the multiples, and I usually do it of the larger number. I list the multiples of the larger number until I find a multiple of the smaller. In this case, I recognize multiples of 12, and so should you and your students. So I'm going to start writing the multiples of 18. 18 times 1, 8. Oh, I didn't even get very far before I recognize a multiple of the 12. Or if necessary, I could start writing both multiples. We have to remember that least common denominator is the smallest multiple, the least common multiple of both. So least common denominator is the least common multiple. All right? So then I have my common denominator. The last tool is the prime factors. I prime factor my 12. And I prime factor my 18. And I assemble the composite. How many 2's do I have to have? I have to have 2 so that the 12 goes in. And then I have to have at least 2 3's. And so here is 36. And you need to show your students this. That's the beauty, let's say, of composites in their prime form. Do you see the 12 literally inside the 36? Do you see the 18 literally inside the 36? So that proves that 36 is the common multiple. Okay? All right, so you're going to be working on your fraction math, working on your chapter review for chapter 2. Let's see. And that is due on Tuesday. All right, we'll see you on Tuesday. And I'll be putting the fraction 2 up on Schoology.